All right, time to get started. So this is now lecture 2. Really lecture 3, but again, we're counting from 0. So you made it this far. We're at the end of the first week. We've done some interesting things so far. We started on Monday looking at pseudocode and English-like ways to represent algorithms, and then on Wednesday we moved into talking about Scratch, which was a graphical interface where you could use puzzle pieces to connect things together and create sort of a program flow. And the first assignment went out Wednesday night. So has everyone at least gotten to look at the problem set spec and has a good idea as far as what's required of them and what I'm looking for on Wednesday?
Yes.
Good. Who has started so far? That's good, most of you. For the ones that haven't started, I'm a little offended. I gave you guys a new toy to work with on Wednesday, and it's just sort of sitting in the back of your closet right now. So break it out, have fun with it, try to use it. You may run into issues, so you want to make sure that after you create your program, there might be bugs, and you want to make sure that you have plenty of time to sort of resolve those bugs. I've already had some people who have programs completed who are in now the debugging phase, and you want to make sure you're not working on it all Wednesday night so that if you do run into issues, you don't have to waste a late day on the Scratch assignment. This is worth 3% of your overall grade. If you waste it on a Scratch assignment, then you're going to run into issues later on when you have the bigger and badder projects. So one thing I haven't really touched on, and I was kind of waiting until this lecture because I don't want to get you bogged down too much into the specifics, but now we can sort of go into it, is how are you going to be graded? So now that you're starting to actually work on these assignments, it's good to know what am I actually expecting of you and what's going to be required when you complete and submit these assignments. And for a programming class like this, especially one of this size, and this, as I said, is the smaller version of the one that I teach. After this, I teach 250 students in the lecture hall of the same materials. There's about 300 students total taking this class. And for something as subjective as programming, it becomes difficult to grade. This isn't like an exam where there is an easy right or wrong question. I'm also not going to create the problem specs in such a way that this is what you have to do, and if you do it, you get 100%. I think part of the experience of learning the program is about exploring, it's about experimenting, it's about doing cool and creative things, and so I want to encourage that. So we really sat down and tried to figure out what's the best and fairest way to grade you in such a way that we can encourage creativity, but also not get bogged down into how these things map into specific grades. So, for instance, if I give you an 82 on your code, and you look at that and you say, I'm pretty sure that's an 88. There's no real way it doesn't map very easily into a number system. And so the way that we figured to work it is we're going to start with a very basic grading system. And so for all of you that complete the project, or each specific project, and fulfill all the minimum requirements, you're going to get a check. This is a way of saying, good job. You did pretty much everything that was required of you, and this is going to be somewhere in the range of an A-, a B+, maybe a B, depending on some other minor things. But overall, good job. You completed the project, it runs, it does everything that it's supposed to do. And then we're going to start adding sort of onto that. So you can take sort of one more step, and if your project is pretty good, as in it doesn't have any bugs, and we look at it and we go, wow, that is a pretty good project, you'll get a check plus. And this is much more closer to our notion of what an A is. And if it still does most of the things it's supposed to do, maybe it has some extra bugs, maybe it doesn't even run completely, but it still has a lot of the main things that we're looking for, it's a check minus. And this is really still possibly a B, maybe on the lower end of a B minus. And so you have sort of these 3 levels of granularity for this check system. And then taking it sort of one more step further, if you show us a program that is just like, wow, it is solid, it not only fulfills all the requirements, goes above and beyond, you have some additional creative things that I might not even ask for, or maybe at the bottom of the problem spec I might say, here are some cool things you can try to implement, and you do, and they're amazing, and they work, you get a plus. A plus is the absolute highest you can get. This is an A+, this is a 100% hands down. If your program doesn't run at all, and it really looks like you didn't try very hard on it, then you get a minus. And so this is really sort of the range of grades that we're going to be working with here. all the way from a minus, which is really a C minus, to a plus, which is the sort of highest that you can get. So most of you will probably wind up getting checks and check pluses, and so these will hopefully wind up working out to a series of good B pluses and A minuses. And sort of the ones that can go really above and beyond the call of duty, then it'll be pluses for you. We will be going sort of one more step, where if you either don't submit the project at all, or it's a flaming pile of crap, you'll get a minus. On the other end, if you submit something that when we look at it, we just start weeping profusely. It is just so good. We have to run out. We have to tell all the other teachers. We have to show this off to the world. You know, you start having an emotional experience looking at your code. That's a plus. So this is extra credit. So if you strive above and beyond, and you start implementing additional things, and it is just so good, you will get recognized for it. You will get credit for it. So I want to strive everybody when they're working on these projects to really do the best that they can. And to sort of give you a feel for, I guess, the rarity of these grades, like the plus, in the entire class, I might give out maybe 25 or so total. And that's not 25 students. That's 25 total across all projects. So these are extremely rare. If you guys are somehow blowing me away, maybe I can get more, but don't be disappointed if you're not getting a plus every single time. But this is, I think, the fairest way that we can sort of work this out. And if you notice, it kind of skews kind of high, so that the average should work out to about a B+. And I don't want to get too bogged down talking about grades today, and so maybe I'll post something over the weekend, and maybe on Monday I'll talk about how these are actually going to map into specific points, and how that's going to map into a grading system where you can eventually determine, well, how many checks and check pluses do I need on these projects if I want to really get an A? Because I'm sure that's what a lot of you want to know. So that'll sort of become clear in time. But use this as a rubric when you're working on Scratch. And when you complete your assignment, think, is this a check program? What can I do to maybe make this a check plus? So something to keep in mind. Any questions with the grading system before I move on? Because I know this is new and it's a little bit different, but I think that it will work out the best for all of us. Good. So we started talking, as I said, on Monday and Wednesday about ways to write code, whether through English-like syntax and pseudocode or through a more graphical user interface like Scratch. Today we get to actually move on to Java. And Java is really, really nice because it is powerful, because of the number of things that you can do with Java. It's going to be a little bit different from Scratch, because whereas Scratch gave you a very finite number of tools that you could work with, in Java, really anything is at your disposal. The number of things that you can tell the computer to do is nearly infinite. To give you sort of an idea of some of the applications that were written in Java, the Hubble Space Telescope, the Mars rover is written in Java, Minecraft is written in Java. Nearly everything in Android itself on your phones is entirely written in Java. And so the level of skill that you're going to develop in this class is going to let you run out of here and eventually go and design the next major application, the next Minecraft, if you will, or maybe designing Android apps or things of that nature. And so the power is definitely there, and that's why we devote one day to Scratch, but now an entire semester, really, to learning Java. And so today we're going to take our first real main leap into what is Java, how do we use it, how do we start to build applications using Java. So what is Java really at its core? Java is, you can sort of boil it down to two things, syntax and its libraries. So the syntax are sort of like its version of the puzzle pieces that were in Scratch. It's the set of tools that you can use to sort of put together in various ways to say what it is you want to say, to tell the program what it is you want to do. And then the libraries portion are really the set of tools that Java gives you. So not the syntax in terms of how you say it, but really the things you can say about, the things that are already created for you. So, for example, if you want to print something to the screen, you don't need to go through and explicitly type out how to send a specific message to your monitor and how to tell your monitor to print which pixels to turn on to print the message you want to print. There's already a library written that you can call, and I sort of invoked it in the program we ran on Wednesday when I wrote the Hello World program. I used printline, and we're going to see that again. Printline is in the Java library where if I pass it a text string, it knows what to do with that. It can take that string and print it to the screen. And so what you'll be using a lot in Java are taking sort of predefined library tools and using them at your disposal. So when you create, say, graphics applications, you won't have to draw the graphics from scratch every single time. There are graphics libraries you can use, or if I say, draw me a bouncing ball, maybe I have to give it the parameters of how big I want the ball to be, and maybe what color I want the ball to be, or some initialization conditions, but then there's already a library element that knows how to draw that ball, and how to do specific things. And so it pulls out a lot of the functionality, so you don't have to implement something from scratch every single time. So now we're going to kind of do a Scratch meets Java and show how some of the puzzle pieces you've been working with in Scratch now compare to their Java counterparts. And so the first thing that we saw in Scratch were statements, where there were specific single-line instructions that you gave to the computer. So, for example, if I wanted to say something, I had the purple puzzle piece which just said say, and I typed in what I wanted it to say. In Java, it looks a little bit more convoluted, but eventually this will make perfect sense to you. So the full sort of puzzle piece, if you will, in this case, is system.out.println. So that is really just a function which does a very specific thing. It prints a line to the screen. And now why there are 2 decimal points that I have to go system.out.println. I can't just say println. This will become clear a little bit further in the course, but for now, just sort of take my word for it that this entire thing is a specific function which does one thing. It prints something to the screen, and that's a statement. Java also has, variables. So we saw variables in Scratch where I could take something like a score and initialize it to 0, and then I could do things to it. I could change its value by some amount. Java also has variables in the same way. You can initialize a variable, which is sort of in the top line, and don't worry about why I have this thing called int in front of the score, but the basic thing that I'm doing in the first line is I'm taking a variable, calling it score, and setting it equal to 0. There's a funny thing, though, that happens in Java with using the equal sign, is that in Java, equals does not necessarily mean equivalence. It means something that we call assignment. So in the pseudocode on Monday, if you remember, I was using sort of left arrows. So I would say something on the right is being assigned to something on the left. And I sort of did that to not entirely confuse you, and to give you an idea of sort of what's going on, that what's happening in an assignment with a variable is you're taking whatever's on the right-hand side and you're storing it in the variable that's on the left, sort of like it's a container. And so this isn't saying that score and 0 are necessarily the same thing. The top line is saying score is a variable, and I'm taking the value 0, and I'm sticking it inside score. And now every time I reference score, I can sort of open up its contents and see what's inside, which in this case is the value 0. And then you can do additional things to it. I can take score and then add something to it. So if you are familiar with any kind of algebra, the second line probably makes no sense whatsoever. How can score be the same as score plus 1? This is because it's an assignment. I'm taking score, I'm adding 1 on top of it, and I'm storing that result in this new value of score. So after I run that second line, score has whatever it had previously, plus 1. And Java gives us a sort of a nice syntax for doing this, so we don't have to write score equals score plus 1 every time we want to increment. There's an increment operator where you just take score and you write plus. And so if you have heard of C and you've heard of C++, this is sort of a programmer's joke, and that's why it's called that. C++ is just sort of the next version of C, which is why it's plus. So in addition to variables, we have Boolean expressions. So in Boolean expressions, in Scratch, we saw you had these hexagonal shapes where you had sort of something on the left and something on the right, and it would evaluate whether that expression was true or false. And on Wednesday, we looked at is 1 less than 2? If it is, it always runs. And then we sort of flipped a coin and took a random number and evaluated whether a random number was less than 10. Java has the same thing, so they're very simple. Just like there is a value and an operator and then a value, Java has the same thing. You can write 1 is less than 2. That's a Boolean expression which will always evaluate to true. You can have a variable and compare that. So I can say x is greater than 5. And of course, if it is, it'll evaluate to true. If it's not, it'll evaluate to false. And then you can get even more complex. I can say, is x less than y? So I'm comparing 2 variables directly. And then Java also has syntax for and or. So I can say, is this thing true? And is this thing true? If they're both true, then do this. And I can also, I don't have it written here, I can write or. I can say, is this thing true? If this thing isn't true, then is this thing true? So is this or this true? If either of them is true, then implement this. And so this is sort of, you can't use one ampersand in Java for reasons that I won't get into now, but the AND operator in Java is AND, ampersand, ampersand. And I'm intentionally running through these things quickly. Next week, we're really going to dive into the whole space of all of these. What are types? What are variables? What are the different types of operators that you can use? I'm sort of giving you a top-level overview right now so you can see everything at once and then dive through maybe over the weekend or during labs on Tuesdays. So these are Boolean expressions, and why did we really want Boolean expressions? Well, we wanted them so we could put them in conditions. So we could say, if something is true, then execute this line of code, otherwise execute this line of code. And so the puzzle piece actually was intentionally set up to resemble the Java syntax. And so you can see that there's an if, just like there's an if over there, where you have sort of the hexagonal puzzle piece where you could place it. You have a condition in Java. And so here I've replaced it with x less than 5. So it's going to evaluate what's in the condition. If it is, it's going to run, do something. And you can see how Java sort of demarcates which lines of code are running in which statements. So it does that by the curly braces. So after the if statement, you'll see sort of a left curly brace. It's going to keep running and running and running everything inside until it sees the right curly brace. And then it realizes, okay, stop. Same thing with the else. You have this entire statement demarcated by the curly braces. And so if x is less than 5, it's going to run only what's in the first set of curly braces. Otherwise, it's going to run only what's in the second set of curly braces. And you can nest these. You can say if x is less than 5, and then inside there, you can put 3 more ifs. But as we'll get to, this is sort of not entirely the best way to write code, and there are better, more elegant ways to do this. So you have conditions. You also have loops. And so this is a little bit more intensive, but give me a second and I'll sort of explain everything that's going on here. So in Scratch, we had a puzzle piece that said, okay, repeat this X number of times. Put in however many times you want to repeat it. Java is a little bit more convoluted. So what's going on here is, let's break this down to sort of 3 sections. There are 3 sections inside this for loop, and they're partitioned based on the semicolon. So you have sort of the first part, semicolon, second part, semicolon, third part. And every for loop that you write is going to have these 3 things. So what's actually going on in this for loop? Well, in the first part, I'm establishing a variable. I'm saying int I equals 0. This is basically a shorthand way of saying, give me an integer, call it I, and say it equal to 0. And I'm going to use this variable within my loop to figure out how many times my loop is going to run. So in the second part, you have what's known as a condition. This is sort of like an if statement, or this is a Boolean expression. What it's basically saying is, run this loop until that condition is no longer true. So as long as I is less than 10, keep running this loop. And the final part, the third part, basically says how you change that variable. Because if you didn't change that variable, then you'd set I equal to 0, I would stay equal to 0, and then every time you want to evaluate, is I less than 10, it would just run and run and run forever. So what this is saying is, when you reach the end of the loop, do whatever is in that third part. In this case, it's increment I by 1. So what's going to happen is, when you first start this loop, it's going to set I equal to 0. It's going to run through the loop. When it hits the end, it's going to say, okay, what's in that third part? Increment I. So now I is going to go to 1. It's going to check the condition in the second part. Is I still less than 10? Yeah. So it's going to run through it again. Increment by 1. I will now be equal to 2. Is I still less than 10? Yes. And so it's going to keep running. And so it'll finally stop when I hits 10. Because then, is 10 less than 10? No. And then the loop will exit. So how many times will this loop run in total?
10 times.
10 times. Because you're going to start from 0, and then once you hit 10, so you'll go from 0 to 9, which is 10 times. And so this is sort of a convoluted way of saying, repeat this thing 10 times. You can, if you want, though, make something run forever, and for that we use something called a while loop. Well, this isn't really running forever, but a while loop says that while this condition is true, execute this. So it's sort of different from a for loop because you're not establishing a variable and incrementing a variable. You just have a very simple condition. This is sort of like taking the second part of the for loop, the I less than 10, and only looking at that and saying, you know what, don't declare me a variable, don't increment the variable, I'm going to do all of that myself. Just check this condition, and while this condition is true, do this. that's sort of like what we were doing with the forever loop with an if statement nested inside. We said, run this forever, and then if this is true, then sort of run this line of code. This is sort of a shorthand way of doing that. And you can make something run forever by sticking true in the Boolean statement, because this will only not run when whatever is in that Boolean expression is false, but if I put true in there, then this will run forever. And so that sort of gives you the same forever repetition that you had in Scratch. So before I move on, are there any questions as far as puzzle pieces in Scratch and how they might reflect the Java syntax? Are we clear on hopefully the beginnings of this stuff? I'm moving quickly intentionally, as I said, but we're going to be fleshing all this out really over the next week. This is sort of like the survey of Java, and then we really drill down next week when we start working with numbers. So I'm going to start today really slow. And I've had a lot of people come to me and say, oh, what program should I install? What special software should I install? And I've been being intentionally cryptic because I wanted you guys to focus on Scratch and focus on pseudocode and not worry too much about it. Today we can really start to sort of pull the top up and say, now what do we really need to start programming in Java? So the first thing that you are going to need is the Java Developers Kit, and specifically version 7, which is the newest version. So if you Google JDK for Java Developers Kit 7, you will instantly be brought to their downloads page, and I will show you what that looks like. So what I had done to get here was literally just Googled JDK 7, and it should be the first link. This is Java SE Development Kit 7, and this will contain all the tools that you'll need to write programs and to run programs. So most of you probably have Java already installed in your system, but what you probably have is more like a Java reader. You have something that can interpret Java programs, but you probably don't have the developer's kit yet, which is what you really need to write the code. So you want to get this Java SE Development Kit 7. And you'll see sort of all these various things that Java has on the left-hand side. It's SE that you want. There's EE, there's ME for mobile devices. Don't worry about the rest of that. And depending on your system, there are a number of different packages that you can download. If you have a Mac, you're pretty easy. There's only one package for you. If you are on a Windows machine, then if you know that you have a 64-bit machine and you know what that means, then maybe you're safe downloading the x64 version. If you either don't know what that means or you just have a 32-bit, you want the x86. So if you're in doubt and you're only understanding half of what I'm saying, this is the one that you want to download. The x86 version, which has this little i586 at the end of it. And then if you have a Linux machine, then you might already be somewhat more advanced, and depending on your processor, either 32-bit or 64-bit, there are a number of different ways to install it. So I'm going to be creating a worksheet that we passed out in the labs on Tuesday. Actually, I'll probably post it over the weekend, and then also pass it out during labs, which will sort of take you through the process of installing Java and creating your first program. But over the weekend, you should try to get this installed, make sure things are running. If not, email one of the TAs, email myself. The TA list will be going up today with office hours, with contact information, which discussion sections they're teaching, so you'll sort of know who your discussion leader is, and you can contact either them or myself for dealing with how to get Java up and running. This is sort of the first real thing that you need to start writing code, and that's the Java Developers Kit. So then, after we actually have that installed, how do we run Java programs? And so I sort of gave a preview to this on Wednesday when I created the Hello World program. We are going to be using a terminal, which is a interface for dealing with your operating system that's not really graphical. And so you may wonder, why on earth are we doing this? Because it really makes running Java programs a lot easier than if we had a GUI. It's going to seem foreign at first if you've never used it before, and not being able to use a mouse at first is going to really annoy and really aggravate you, but by the end of the semester, you will be a power user, and you will be one of those people that just goes, and will do it instantly what you want to do. I promise. It's going to take time, it's going to take a little bit of pain, but you will like it by the end, I promise you. So how do you get a terminal window? If you have a Mac, again, they make this really easy for you. I think you can go into Utilities and then just pull up a terminal window, and it should be pretty straightforward. Yeah, I don't have a Mac to demonstrate, but it's in Utilities, right?
You just go to Apps.
You go to Apps, and then it should be there in your Apps. And so you can have a terminal window to sort of mess around with. And it's the same as the Linux terminal. If you have a Linux machine, again, this should be natural to you because Linux makes using the command line terminal a natural part of the experience. If you have Windows, as I do, then there's just a tiny bit of pain, but it's easy to overcome. You have to use this tool known as Cygwin. And so the worksheet that I hand out on Tuesday and post over the weekend will sort of show you how to install Cygwin. What is Cygwin? It's basically a command line interface that runs as if it were a Linux machine. So if you have Windows, you might be familiar that Windows sort of has its own command line. It's CMD, if you will. It's really not good. Windows has they're really content with having their own sort of proprietary idea so that they're different from Mac and different from Linux, but it's altogether bad. What we want to be using is a Linux terminal for this, and so you'll have to download Cygwin. And this is also easy. If I open up my browser, I can Google Cygwin, and it should be the first thing that pops up, cygwin.com. And so you'll want to go and install it. Running this setup x86.exe, it should be pretty simple. And then what you'll get as an end result is this, a terminal window that you can then play around in. So what are we going to do right now? We are going to play around in this window and show off a couple of things that you can do at the command line. So let me make sure that this is highly readable for all of you. Okay. So when you first boot up your terminal, and actually I don't want that to be all the way at the bottom. Let's raise that a little bit. Okay. You're going to see some kind of cryptic command and then a $sign. And I'll probably explain in the handout what this actually means, but this is where you can type commands and sort of explore your operating system. So the first thing that I showed off on Wednesday was the ls command, which is short for list. And if you're in a directory, you type ls to show you the contents of your directory. And so right now I'm actually in this lecture sort of folder, and so you can see some things in there. The lecture notes that I've been showing off, some of the images that I used in it. And so you can sort of jump around. If you want to create a new directory, it's a command mk for make, dir for directory. When these things were sort of invented in the 70s and the 80s, they wanted to keep the syntax really short, and so there's a lot of sort of shortened commands. So make dir is going to make a new directory, and if I hit spacebar, I can type in what I want the name of that directory to be. So for today, let's type code. We're going to have a code directory. So if I hit make dir and then code and then enter, it looks like nothing happens. But if I type ls for list to list the contents of my directory, you can see that whereas before I didn't have anything, but now I have sort of my little code directory in there. So now that I have my code directory, how do I actually go inside and start making things? There is a command known as cd for essentially navigating through directories. So if I type cd and in the folder that I want to go into, code, then it will take me there. And if I type ls, nothing will happen because I'm now inside of the code directory. And because I just made a new directory, there's nothing inside there. This can get all really confusing, and it might seem like it's simple to get lost when you're in sort of the Linux terminal. I don't know where the heck I am. Right now I'm in an empty folder. How do I figure out where I am? There is a command called pwd. And again, I'm going to be putting all of this sort of in a tutorial worksheet. So I'm running through commands quickly, but you guys will sort of have all of the commands and what they do at your disposal within the next couple of days. So pwd is short for, well, I don't know what the P stands for, but the WD is working directory. It's going to tell you what directory are you in right now. So this is telling me sort of I'm in, so Cygwin uses this thing called Cygdrive just to store where its file system is, so don't worry as much about that. So I'm in drive E, and then I'm in a folder called class, lectures, lecture 2, which is what this is, code. And so if you ever get lost, you can hit pwd to sort of figure out where you are in the system. So now I'm in the code directory. How do I get out of the code directory? Well, I can go sort of one directory level up, which would be lecture 2, by typing cd again. This is sort of your navigation commands, and then a dot. That will bring you up a directory. So if I do that, and now see pwd, where am I? Now I'm just in lecture 2. And if I went to list the entire directory, now I can go back to what I had before. And likewise, you can then quickly navigate to sort of any part of your file system by typing cd and then the path. So if I wanted, I could type cygdrive/e/class/lectures, and get back to wherever I wanted to get to. And this seems like it is really convoluted and might take a long time. And why would you ever want to type out the path fully? One thing that Linux does, is particularly the command line does, that's nice, is it has this feature called autocomplete. So if you start to type part of a folder name and you hit tab, it'll autocomplete with whatever is sort of left in that folder. So you can navigate to places in your hard drive really, really quickly. And this is one of sort of the nicer things about a command line interface than, say, a Windows interface, where you have to click and then click and then click. I can type, say, Cig, and then because there isn't any other folder in this other than Cig drive, by hitting tab, it'll immediately tab to Cig drive. If there are multiple things and you hit tab twice, it will sort of tell you what your choices are. So if you're trying to navigate and you forget, oh, what's the name of that folder, then you can hit tab twice and pull up the list of folders that you have. So here, I have a C drive, I have an E drive, and I have a T drive. And so I can go to my E drive. Well, what are my folders in here? I have a lot of things. So I can go to my class directory, CL tab, L, how many L's do I have? Well, I have a couple things. Select, tab, and then so forth. And so it's pretty simple to start sort of navigating around. So let's go into the code directory, which is now empty, and let's make something. Let's go ahead and sort of recreate the first Hello World program. But on Wednesday, if you remember, I pulled up the Notepad. And you can use any text editor that you want to create Java code, but what I'm going to try to introduce in this class, and eventually the goal by the end is to sort of turn us all into hackers and code junkies. And we sort of all have our little tools that we like to use, and so I'm going to share another one of those tools with you, and that is Sublime Text. And that's just sublimetext.com. What is this? It is basically a text editor just like Notepad, except it has a lot of really cool things and cool features that will make it simpler for you to write code. And so if you download that and install it, and I will open up the version that I have right here, you can see it looks very similar to Notepad. I can type things, and there doesn't look like there's very much more functionality. There's not as much overhead as if you were using, say, Word, where they have sort of all these menus on the left and the right and the bottom, and a paperclip jumping out and telling you how to do very many things. It's very simple, but very powerful. So I'm going to put this into a configuration that will probably wind up becoming standard for you guys. So one thing that you might want to be able to do is edit text as well as run your programs at the same time. And so what we programmers usually like to do is we consider screen real estate to be really important. And so we're always sort of resizing windows and trying to fit as much on the screen as we can. And so what I'm going to do now is try to run, actually this might be easier if I run this on the top. So I'm going to stick my command line window and resize it up here at the top, while also having my my text window here at the bottom. There we go. So now I can do things. I'm going to edit code, and then I'm going to go and run that code in this little command line here. And by sort of resizing windows and making things perfect on the screen, it'll make things easier than just sort of clicking and having to constantly switch back and forth. So why is Sublime Text so nice? Well, I'll show you by writing the first program. And so to sort of reconstruct the Hello World program that we had before, I typed public class hello, and again, you're not supposed to know what this means. And the first thing will become apparent when I open my curly brace. I get sort of an autocomplete with the right curly brace. After you've written enough code, you will learn to love this feature. So you don't have to constantly tab down and close off the curly brace. It automatically does it for you. And if you hit enter, it will automatically sort of put it on, oh, you guys cannot see this at all. There we go. It'll sort of put it off to the side and let you type freely with whatever's inside. So as we saw with the if statement as well as the loops, things inside curly braces sort of demarcate lines of code. They demarcate sections through which code is going to run. And so don't worry about what a class is yet. We're going to get to this in more detail next week. But if I type public static main and then string args, I have another curly brace. I'm sort of doing some mumbo jumbo to get to the actual program that I want to run, which I'm going to type the same say statement that I showed you guys earlier, which is system.out.println, and then I'm going to type something in here. I'll recreate hello world, and then close this off with a semicolon. And so if I go to save this, something really, really nice will happen. I'm going to save this in the same code directory that we had created, and I'm going to call this hello.java. Every Java file that you create, you'll want to leave with the extension Java, so that when you compile it, it sort of knows that this is a Java file that it wants to compile. And watch what happens once I save this as a Java file, and then Sublime Text recognizes that what I'm working with is actually a Java file. Syntax highlighting. And this is your best friend, and this makes it so much nicer than Notepad. So you can use syntax highlighting to sort of figure out what are the code words in Java and help you remember some of the syntax. And so I'm not going to get into too much detail with what some of these specifics are, but you have certain keywords that are in pink. Methods and functions that we'll be dealing with will always be in green, so you can sort of quickly look at all of your code and immediately tell where are the functions. Arguments to functions will always be in this sort of orange. Strings will be in this yellow, beige-ish kind of color. And so by sort of teasing out all these various components, it'll make it a lot easier when you're working with your programs to see what's what. I also personally happen to like sort of the black background with the white text. I think it's, when you've been doing a lot of coding, it makes it a lot easier on the eyes than sort of black against white. And you'll notice a lot of programmers using sort of this inverted layout. But feel free to use either. I think you can change this to a white background with black text if you want. It's completely up to you. So what is actually going on, forgetting these little bits of mumbo jumbo on top, is that I created a statement. I created hello world. And using this convoluted say puzzle piece, basically, I'm telling it that I want to print it. So how do I go ahead and run this? Well, I use a command in my Cygwin known as javac for Java compiler. So I talked about this on Wednesday, where right now my code exists as as Java code, as sort of English-like code. But what the computer knows how to run are only ones and zeros. So I need a way of converting this code on the bottom to ones and zeros. And so that's where the compiler comes in. The compiler converts it into what we call bytecode, and then the actual Java program runs that bytecode. So if I type in javac and then the name of my program, and one nice thing also about the command line is, let's say I forget what my file name is, you can use tab autocomplete again. Because there's only one file in this folder, by hitting H and then tab, it's immediately going to autocomplete it for me. So javac and then the name of the file, hello Java. It runs for a couple seconds, and I have my first bug. Error, invalid method type declaration. So I did something here wrong. The return type required. And I actually forgot a little keyword. This will make no sense to you right now, but probably by next Friday it will make a lot of sense to you. And so you can sort of see one feature of the compiler is that it will point out parts of your program that are wrong. And I'll do a little bit of debugging here in a second. But first I want to run this successfully. So javac took about 1 second to compile. So now it exists in bytecode form. And if I type ls for list to see what's in there, I now have two files. I have the original hello.java, which is this file that I've created. And I also have a class file, which is the bytecode file, which has the zeros and ones that Java knows how to interpret. So if I then type in Java, now without the C, because I'm not compiling it, and then just the name of the file. And this gets a little confusing because you don't need to type hello.class. Java accepts only one type of file. It only accepts class files, and so you don't need to specify. You can just type hello, and it will immediately go seek out hello.class. And if I do that, it should do exactly what I programmed it to do, which is print out on the screen, hello world. So now let's start sort of adding things to this. So this is where we sort of got to on Wednesday, and then we stopped and moved over to Scratch. And so now we can start really developing our toolkit a little bit. So the first thing that I want to introduce is a variable. And I might want to make this text a little bit bigger so that we can all make sure that we can see it. Where is the... I actually usually use a different editor, and I'm learning to use Sublime myself. Okay, I'll leave it the way it is. I'll figure out later how to make the text bigger. See, it's so simple that they remove even some of the easiest features out so that they don't complicate things. So what I want to do first is rather than giving it a string, so this function, print line, can do a number of things and it can accept a number of inputs. For instance, one thing that I can do is I can declare something, let's call it a phrase. I'm declaring a new variable and I'm assigning it a certain value. In this case, let's assign it hello world. So what have I done here? Well, this is sort of the same phrase that I had before, and I'm using the assign statement and sticking it into this variable called phrase. But why do I have string here? String denotes the type, and I'll get more into types on Monday as to why I specifically have to use this. But what you're basically doing is you're telling Java, the variable that I'm using, this is what it's going to contain. It's going to contain a text string. And that's important when Java tries to figure out how to store it, because one of the reasons that Java is really quick is that it can store things efficiently because you're telling it what you want to store. Question?
Is case important? The ITI string in system.
Yes. So case will be important. If you type in a lowercase string, this won't recognize it. And this is one reason why code highlighting is nice, is I can see it's in white, it's not recognizing it. It doesn't know that it's a type. And so I have to capitalize it. And we'll delve into a little more detail as to why case is specifically important. There is actually a class. So just like here, I have a class hello, and I'm defining what that class is doing. There is a class somewhere in the Java library, and again, this is why libraries are important. There's a class called string, and I'm sort of invoking that class. And string has a bunch of things that it knows how to do. I'm just pulling that out of the library. So I create a phrase, hello world, and now I can just pass the actual phrase in instead of hello world. And so if I save this, go back and recompile, and so another nice thing about the text editor, if you're typing a lot of commands, and especially if you're being repetitive, you can hit the up key to go to the last thing that you typed. So if I hit up 3 times, I'll go back to my Java C and I don't have to retype it. So I'm going to recompile this, and then it still prints hello world. And so what's happening is it's taking the variable, and so now you can sort of create variables and use them in all of your computation. Another nice thing that strings can do is you can sort of add strings together, and this is where variables become really powerful. So let's say rather than saying hello world, I want to say hello something. And for my phrase, I'm going to say COP35. What I can do is I can concatenate 2 strings together. I can sort of add them together with a plus sign. So if I say plus phrase, what's happening is it's taking 2 strings. It's taking hello, comma, space, and then it's taking another string, which basically is taking this variable and depositing it. It's basically replacing it with what's contained in phrase. And so now, when I rerun this, it should say hello, and then what's in the variable. So I'll recompile, rerun it, and that is a bug because I didn't save it. Now that it's saved, recompile, rerun. There we go. Another thing to note, so why do I have semicolons here? Semicolons let you know where the end of a line is. And so when you are running through your various programs, you'll always have to put a semicolon at the end of each line so you can tell Java sort of, this is my statement, and not to run over, because Java sort of collapses all of the white space in your program. So if I wanted to, I could have taken all of this and put it into one line, and Java would process that completely fine. In fact, that's actually what Java is doing. So you have to let it know where the ends of your lines are. And I can tell you from experience, the most common problem that you will run into is forgetting to put a semicolon. And you will debug for a very long time sometimes before you find the semicolon. So try to get into the habit and practice of constantly putting your semicolon. So let's look at what would happen if, let's say, we don't put a semicolon. Well, I guess we saw that earlier because, we saw the type problem earlier. So if I compile this now without the semicolon on the phrase, it's going to shoot me an error. And it's going to say, specifically, semicolon expected. So sometimes the compiler will help you out, and it will immediately notice, this is not a good Java program. There is something wrong. What is wrong with it? Well, there's an error at line 4, so I'll go down to line 4 right here, which is exactly where this is, and then stick the semicolon in. there are other errors that you can make. So let's take a look, I guess, at some of the errors that one might run into in the last few minutes here. We saw what happened if I didn't include this type right here. What happens if, let's say, I type the function wrong? So I'd say print n instead of print line. And this is also part of sort of the exploration of computer science, is if you're not sure what these things are going to do, go try them out for yourself. Try to break Hello World. I guess that's probably what I'll make the homework for this weekend, in addition to the Scratch project. Create Hello World, and then figure out all the ways that you can break it. Figure out what the errors are going to look like. So I'm typing print n, which is not a valid function. And if I compile this, it's going to tell me, and I'll make this a little bigger, that it cannot find this symbol. It doesn't know what the heck this means. And so it's of a specific type, and we'll get to types more on Monday, but specifically it can't find this on which line? Line 6. So lets me know that I want to go ahead and include that. So because I have a few minutes, I'll go ahead and explain what's basically going on here. So this is your main block. Every time that you write a program that wants to run, you're going to have a main block. And so the main, in green right here, this is sort of the name of a function. And so we saw functions briefly in Scratch. You could sort of define specific blocks that did a long line of computation, and then you could just sort of call that block, and it would do all of that computation. Well, this is a function specifically called main. And every time you run a Java program, it will look inside your code and look, where is the main function? Specifically, what is enclosed by this curly brace and this curly brace inside your main function, and that's what it will run. There are additional sort of parameters here that I will explain in more detail, but the main thing to sort of understand is I've created a class called hello. This is an object, and I'm intentionally just sort of throwing out terms here that I'll explain later. So this is a hello object which has a method inside of it. That method is called main and will run specifically. So when I type Java hello, what it's actually doing is it's going to go to the hello object. So it's going to look for public class hello. And so one thing that I will harp about when we get to objects is that whenever you have a class, you have to name your file with the same file name as your object itself. So when I type Java hello, it's going to look where is the Java object in the Java class file, and then once it sort of dives in here, so this is what it's looking for, then it's going to look in there, where is the main function? Once it finds the main function, it's then going to go ahead and run whatever's inside here. Any questions here with your very brief sort of tutorial into Java syntax?
Professor,
can you see this, by the way? I guess, should I go over the way?
But it's fine. If we have void, we don't need a constructor for our object.
So you're throwing out terms which I don't want to get to just yet. But if you have void, you might still need a constructor. So void deals with the type that the function returns. And so I guess as a very brief preview is that functions cannot just compute things, but they can give you things back. And you have to specify when you're creating that function, what thing am I getting back? Am I getting back an integer number? Am I getting back a string? Using the void command, that's basically saying I'm not getting anything back. I'm just going to do this thing, and it's not going to give me anything in return. So that's sort of your first keyword that you'll learn. Okay, so we'll end it there, and keep working on your Scratch project. I've seen a couple of things so far, and I'm really, really impressed. Good job. Keep at it. Office hours will be posted later today, and we'll start officially next week. And I'll be explaining what's going on in discussions on Monday.